boards are typically fabricated in arrays, and then, after they go through the assembly process, the individual boards are separated or depaneled. For the designer, this means that once you complete the board layout, you need to create an array drawing. Fitting as many boards as possible into a standard panel will help minimize material costs, but of course you also need to think about the manufacturing costs. If your contract manufacturer has an in-house engineering department, you should definitely ask for their help with this. At Z-Axis, our design engineers are happy to create the array drawing for you, whether you've done your own design and layout or used our services for it. The design engineers will work with our manufacturing engineers to determine the best depaneling process for your design and create the array drawing accordingly. So let's look at some of the different depaneling tools and methods that we use at Z-Axis. For rectangular boards, the PCB panels typically have a V-score, where the boards will be separated after assembly, but you can't just snap it along the score like this because stresses in the board as you bend it can damage SMT components. We use specialized tools to separate the boards with less bending stress. One is a guillotine, which we use for thin boards. Another depaneling machine, often called a pizza cutter, is used for thicker boards. Curves and other shapes will come pre-routed with tabs or drilled perforations. These boards can be depaneled using a punch, which is tooled to fit the board design. A hook tool is used for separating at tabs. It leaves mouse bites that may need to be sanded off. Some manufacturers use a mechanical router, which creates less strain but more vibration stress and a lot of dust. All of these methods do cause some mechanical stress on the board and require that parts be kept a safe distance away from the edge to avoid damage. Ceramic capacitors are particularly susceptible to cracking, as are end caps on resistors. A newer method for depaneling eliminates this issue altogether. This UV laser cuts PCBs with zero mechanical stress. It makes extremely narrow, very precise cuts in any shape. Laser cutting lets us hold very tight tolerances on the finished assembly side, much tighter than you can get with a pre-routed panel. This is a big advantage when the exact board size is critical to the finished product, which we are seeing more and more often as boards go into smaller and smaller products. Laser cutting also allows components to be placed much closer to the edge of the board, helping you maximize the use of board space in very small PCB assemblies. By understanding the different depaneling methods available, you can work with your contract manufacturer to create an array drawing for the depaneling method that will give you high reliability, low material cost, and the right balance of throughput, manufacturing cost, and precision.